secara kompeten agar menghasilkan output yang dapat mendukung program pusat riset arkeometri dan secara luas untuk mendukung program pemerintah. Mewakili kepala dan panitia seminar ini, kami menyambut hangat kehadiran Bapak, Ibu, dan saudara-saudara sekalian dalam acara ini, dan semoga dapat memberikan manfaat bagi kita semua. Yang akan menjadi keynote speaker kita kali ini adalah Bapak Dr. Richard Meyers dari Komisi Arkeologi Budaya Non-Eropa dari Institut Arkeologi Jerman. Penyampaian presentasi akan dilakukan dalam bahasa Inggris. Good day, my name is Marlene Tola from Research Center of Arkeometri, and it's my honor to be your master ceremony for the second episode of our public lecture series with the topic Geochemical Fingerprinting of Archaeological Remains, Current State and Development. On behalf of the lecture organizer, we extend our appreciation for your presence today. Our keynote speaker in this section is Dr. Richard Meyers from the Commission for Archaeology Non-European Culture of the German Archaeological Institute. Guten Morgen, Herr Prof. Meyers.
Thank you very much.
Okay.
Ja, ich kann Sie hören, ja. Ja, thank you very much, I can hear you.
Und hoffe, dass Sie Gefallen an unserem Seminar finden. Okay.
Wow.
Okay,
Können Sie mich hören? Did you hear me?
Yeah.
Did you hear me? Yeah, okay, excellent. Wow, thank you very much for the German. That's much better, unfortunately, than my Bahasa Indonesia. So I'm very pleased. Thank you very much. It's going to join my or share my screen now, if that's okay.
Okay, noted. I will run. I will still running with the agenda. Maybe later, Prof. We'll go in this section later. So the first item on our agenda is the welcome speech from the head of Research Organization for Archaeology, Language and Literature National Research of Innovation Agency. And secondly, there will be the public lecture from Dr. Meyers, and this section will be guided by my colleague Anton Verdianto. And the third closing statement from Dr. Meyers and Dr. Sofia Norwidi as the head of Research Center for Archaeometry. And without further ado, let us now start our program by welcoming the head of Research Organization for Archaeology, Language and Literature to deliver his opening remarks, Dr. Heri Yogaswara. Kami persilakan Bapak untuk menyampaikan kata sambutannya. Silakan.
This is in English or in Bahasa Indonesia?
Indonesia boleh Pak, mungkin terserah Bapak.
Okay.
Silakan.
Okay. Selamat siang. Good day. I don't know what time now in Germany. And then welcome to welcome to Research Organization of Archaeology, Language and Literature, or of the National Research and Innovation. Maybe for the participants who are not familiar with the new organization in Indonesia, the archaeology right now is belong to Research Organization of Archaeology, Language and Literature. And in the research organization, we compose of 7 research center, and then the 3 research center related to archaeology, namely archaeometry, archaeology history and prehistory, and also archaeology related to maritime and sustainable culture. Of course, I really happy to have Dr. Richard Meyers, researcher from the Commission for Archaeology Non-European Culture, KAK of the German Archaeological Institute, DAI, can speak in the I think entitled related with what is geochemical fingerprinting of archaeological remain current state and development. I think even I myself not an archaeologist, but I think this is a very important title and also very important theme related to the research area of archaeometry. I think that's why I really happy to have public lecture this afternoon, and I hope all participants who are interested with these issues can get inspiring also knowledge related with this topic. And again, I would like to say thank you to Dr. Christian Meyers. I hope this webinar will be our collaboration begin related with the Research Center for Archaeometry. And then to all participants, again, I hope this webinar can give new perspective, new knowledge related with the archaeometry issue. Again, thank you for all, especially for Dr. Christian Meyers, and I hope I hope we can work for others collaboration for the next future. Thank you.
Oke, terima kasih atas sambutannya Bapak. Sekarang kita akan lanjutkan dengan acara inti yang akan dipandu oleh Mas Anton Ferdianto yang juga akan memandu kita dalam diskusi. Silakan Anton.
Terima kasih Mbak Marlene. Thank you very much. Good afternoon, everyone. Before we start our lecture series today, I would like to introduce our speakers, which is Dr. Christian Meyers, holds an MA in Archaeology, Cultural Anthropology and Geography in 2003 from the University of Cologne, and a PhD in Prehistory in 2010 from the Australian National University. After a postdoctoral fellowship in the highly competitive Australian Research Council Discovery Early Career Research Award at the Australian National University, he was employed as senior lecturer in archaeology at James Cook University, Cairns, Australia, until 2021. He published numerous scientific journal articles. These include articles in high-ranking international journals such as Nature, Proceedings of the National Academy of Science, Journal of Archaeological Science, and Antiquity. He is an Alexander von Humboldt Experience Research Fellow in 2020 and holds Senior Research Fellowship at the Max Planck Institute for the Science of Human History. There's too many. There's too many stuff need to explain, but anyway, right now he's a researcher at Commission for Archaeology Non-European Cultures of the German Archaeological Institute. So without further ado, I would like to invite Dr. Richard Meyers to start his presentation, please.
Okay, thank you very much. All of these institutes are quite a bit of a mouthful. So
exactly.
Can you see my talk?
Yeah.
I'm just gonna push so that I can see who everybody is on here. Okay. All right. Wonderful. Thank you very much for this really lovely introduction. And I'm really happy to be here. So dear colleagues, first I would like to apologize that I will give this talk in English. My Bahasa is unfortunately not good enough to lecture, and I'm truly sorry for this. I would also like to offer my sincere thanks to Ruli Fauzi for organizing this event, and I appreciate the opportunity to present some of my work here. Ruli Fauzi asked me to give a short introduction into my provenancing work, but I also provide some technical background on how to do provenancing. And I hope I will not bore the specialists in the audience too much with this talk. In considering the task, I have structured my talk today a little bit counterintuitive. After a short introduction where I focus on the basic concepts of provenancing, I will start with the interpretation and then work myself backwards towards the original fieldwork at the end of end my talk with a short statement of what I think should be focusing on understanding obsidian exchange in Indonesia. Okay, let's jump straight in. What I want to talk about today is called provenance in archaeological research. In the most basic terms, we are comparing elemental composition of two materials. These two materials can be artifact and source, but can also be artifact and artifact. And we do this to understand the origin and distribution of certain materials to explain, for example, population movements or trade and exchange or social networks in general. This is done by the geochemical analysis of raw materials. One way to visualize the concept of provenancing and also your geochemical data in more general terms, I present you this chart. If you read the geochemical literature, you come across these type of charts very often. They are called spider diagrams and have a series of elements on the x-axis and logarithmic transformed abundances on the y-axis. The order of elements is not random, but I don't want to go into too much detail about this. On the chart, you see 4 different series here. And these are all obsidian artifacts from Western Polynesia, and you can see 2 different groups. If the groupings are matching this closely, you have a high chance that you are looking at 2 sources. But you can also see that there's 2 sources quite similar to each other, which is one of the core problems in provenancing research. More to this in a bit later. Archaeological provenancing is based on only 3 premises. The first one is that different samples of material from a single source are of uniform composition. And you can see here 2 XRF analyses compared to each other. This means that there's characterizability. The elemental signal is homogeneous and in particular source. When you analyze different spots on the same sample, you should get a similar composition in your geochemical signature, depending on the error of your analysis. The second premise is that there are compositional differences between samples of the same material from a different source. The sources should be unique. An overlap between geochemical composition is a common problem, which sometimes necessitates that we are using high-resolution techniques to distinguish between sources from each other. And finally, that such differences can be clearly recognized and distinguished. They have to be predictable, so there's no human processes should affect the elemental signature. Sometimes provenancing is difficult because human processing, which changes the elemental composition, for example, of clays. For ceramics, we try to compare not only the geological sources of clay, but to also to waste production sites, which are vessels who have failed in the burning process and dumped close to the production site. They should be measurable, so analytical methods should be employed which have sufficient accuracy, and they should be stable, so post-depositional alterations should be negligible. With these basic principles in mind, let's talk about one example, the obsidian networks in Indonesia, particularly in the islands of Nusa Tenggara. This has been one of my focuses with Sue O'Connor and her team from the ANU. I got involved on these projects as a geochemical specialist, particularly analyzing obsidian assemblages, which are in part substantial. In the following, I will highlight 3 rock shelters to investigate the timing, spatial extent, and changes in source exploitation. The first part of this research framework was investigated and published in 2016, where we were able to show that there is substantial evidence for interaction appearing in the archaeological record around 15,000 to 12,000 years ago, with the transportation of obsidian artifacts from no so far unknown obsidian source in the region. What we can see here is that at least 3 obsidian sources were utilized in this region. We named them group 1, 2, and 3. Group 3 obsidians, represented in gray, red, and yellow, were suggested to be one lava flow. Initial research at the Tronbon-Lay rock shelter on Alor revealed 13 well-stratified layers, which included discrete features such as arcs and layers of flowstone. Radiocarbon dating suggested 3 main phases of activity at the site. The late Pleistocene, late last glacial maximum at circa 21 to 18,000 years ago, the terminal Pleistocene to early Holocene transition around 12,000 to 7,500 years ago, and the late Holocene pottery-bearing deposition after 3,005 years ago. Aside from obsidian, stone artifacts were manufactured primarily from basalt, with small numbers of shared artifacts also recovered. Tronbon-Lay revealed an interesting chronological distribution of obsidian artifacts. it appears that there's a marked change from locally obtained obsidian in the lowest layers of group 1 and 2 into the later periods. We see a pattern of increased usage of group 1 and 2 sources starting in around 12,000 years ago, so down here. In red, group 3 artifacts in red appears in the lowest layers, but becomes less important in the later time periods. Oops. Besides the appearance of obsidian at certain point of time, there seems to be also a relationship with its distribution and the earliest peopling of small islands in Nusa Tenggara. The example rock shelter here is Heresoto and Tapa on Kisa Island. Kisa lies approximately 25 kilometers northeast of the island of Timor and is an uplifted island in the active Banda R continent collision zone. Today, Kisa has a total land area of only 81 square kilometers. It has a narrow coastal platform owing to its rapid rate of uplift and deep offshore profile. The steep offshore profile means that its land area has changed little during the sea level fluctuations of the last 50,000 years. Even during periods of maximum low stand, it would never have been much larger than today. Kisa originated from the uplifting high-pressure metamorphic rocks. The island is almost completely encircled by a series of quaternary coralline limestone terraces that run parallel to the coastline. No extrusive volcanic rocks can be found on the island. Heresoto and Tapa rock shelter is located about approximately 100 meters from the coast and about 24 meters above mean sea level on the south coast facing Timor-Leste. Heresoto and Tapa deposits can be divided into broad chronological phases. Phase 1 begins with the initial occupation around 15,000 years ago and continues until the early Holocene around 9,500 years ago. The second phase of occupation commences about 4,900 years ago and continues until about 1,800 years ago, and is more recent with a hiatus of occupation in between. Multivariate statistics using discriminant function analysis of the geochemical results from HSE show dominant utilization of 1 obsidians. A single artifact in XU17 was tentatively sourced to group 2. The difference between group 2 confident intervals and the artifacts derives from relatively high manganese values, which might be machine introduced. Looking closer at the distribution of obsidian through time, it becomes clear that there appears to be a strong influx of exotic obsidian raw material at the beginning of the sequence. This more intensified use seems to disappear relatively quickly once the island is occupied and do not appear again in phase 2 times, which is associated with the spread of Neolithic communities in the island. The last rock shelter I would like to present is Magpan site on the west coast of Alor. The stratigraphy revealed 18 layers with a very slow deposition of sediments in the lowest layers, which significantly increased at around 12,000 years ago. There are 5 phases of occupation. The occupation starts in the late Pleistocene around 43,000 years ago and ends about 28,000 years ago. Phase 2 dates into thermal Pleistocene with an onset about 13,000 years ago. It has about a 1 meter sedimentation, which was deposited in less than 2,000 years. The Pleistocene-Holocene transition is represented through a substantial shell midden deposit at around 12,000 years ago. The early to mid-Holocene at around 10,000 years ago is the 4th phase of occupation. There appears to be a short hiatus in the occupation between phase 3 and 4, and the last phase of occupation dates to the post 3,600 years ago and are the upper Neolithic pottery-bearing deposits. Obsidian exploitation is slightly different than the previous presented rock shelters in that group 2 dominates the assemblage. We might see the western extent of group 1 obsidian's interaction network as we only have found one piece of obsidian, group 1 obsidian in the whole assemblage. Group 3 obsidian, local to Alor, only appears in the lowest layers, with the exception of a brief occurrence in spit 17. Magpan obsidian distribution revealed that there are 2 subsources of group 2 obsidian, here in the two green colors here, which are not which we were not able to distinguish in the assemblages before. Furthermore, group 2A and group 2B are not similar in quantities throughout the sequence. Group 2A is dominating the earliest and latest deposits, and group 2 is dominating throughout the phase of intensive sedimentation in the terminal Pleistocene to early Holocene transition. Unfortunately, we don't know the location of group 2 obsidian yet, and to determine further whether this represents a real spatial change of different source localities. So how does this picture look region-wide? We have analyzed obsidian artifacts from 8 rock shelter sites, and we see an interesting distribution. There seems to be an overlapping interaction zone of obsidian. Group 3 obsidian on Alor is only found on Alor. Group 2 obsidian, of which we don't have an exact location of the source, is mainly distributed in the west and on Kisar in the east. The widest distribution has the group 1 obsidian, which is found mainly in the east, but also occur in larger numbers on Alor, in Tranbon-Lake. If we compare the abundances, it appears that group 2 obsidian might be located closer on Alor, with abundant material having been found in Magpan. More than 95% of the material is from there. It might necessitate to extend our surveys to the western side of the island. Taking Kisar into account, it appears that group 1 obsidian might be located closer to the island. We have previously suggested that islands of Wetar are a possible source for group 1 obsidian. This not only derives from the geochemistry, but also from the technological analysis, which show that there might be a slight difference in artifact size and cortex abundances. The spatial distribution of the source abundances certainly supports this interpretation. So why does this raw material transport network exist? And here the interpretation becomes interesting. The interaction network did not start when people colonized Sahul some 60,000 years ago. Therefore, these networks are not necessary to cross the island landscape of Wallacea. They also didn't start when the sea level was at its lowest during the last glacial maximum, making the distances between islands smaller. Only local obsidians have been exploited throughout this phase. It started during a period of very fast sea level rise during meltwater pulse 1A, where sea levels rose from -90 to -50 meters in a few centuries. Although large land masses in the regions were inundated, islands with steep topography actually saw an increase of maritime productivity because sea level rise creates new environments for coral growth. This might have been a pull factor for population to engage with more maritime activities. At the same time, there was an increase of rainforest extents in the inland regions of the islands, replacing more open woodlands. Whether these vegetation changes are major push factors for people to engage more with coast is unclear. So now that I presented some of the interpretations of a possible obsidian interaction network, I'm very happy to discuss the results later in our discussion. What data do we need to come to these conclusions? Our interpretation of the distribution patterns of obsidian is based on geochemical data, which is mostly created in the lab by analyzing source material and material from sites. The most common used techniques in sourcing obsidians are still neutron activation analysis, X-ray fluorescence analysis, XRF, and electron microprobe. Although most of them are now replaced by portable XRF analysis, and to this a bit more in a second. Mass spectrometry, either as laser ablation or in solution, is a method of choice if you need isotope ratios, particularly if you're looking at very low amounts or if you're looking at heavy isotope ratios. Most other analyses look primarily at the concentration of elements in the sample. Of these, NIA is the most accurate and precise technique. However, it is restricted on relatively few elements and it's quite expensive. Geochemical fingerprinting doesn't just work on obsidian. However, obsidian is one of the easiest source to source materials. This is just a reminder that a lot of different archaeological materials are analyzed geochemically, and not every technique is perfectly suited for every material. Particularly if you want to analyze organic materials such as pigment binders or different types of ores, or if maybe very light elements such as calciums and shells is your interest. The good thing about Obsidian is that it's an ideal material for geochemical analysis, as it fulfills the precise outline, the premises outline in the beginning of the talk perfectly. So the material is homogeneous, the sources are unique and discretely distributed, and it can be easily analyzed with geochemical techniques. So, however, if you think about the technique to use, another decision needs to be made, whether you are allowed to use destructive techniques on your material. This is usually not a problem for geological material. However, if you analyze artifacts, particularly from museum collections, this becomes of utmost importance. For this reason, some analysis, for example, NIA or AIS ICP-MS, which from archaeological perspective need relatively large sample materials, can't be used in a lot of cases, although they are the some of the most accepted geochemical analysis in geological research. Here are a couple of examples for destructive analysis of my work, which LIICP-MS and EDXA. Although both of these techniques are identified as minimal destructive themselves, the sample preparation of both analyses can be quite destructive, considering that they can be very expensive to run, and you are hiring the machine usually per hour of analysis time. In my work, to get a balance right between destructiveness and efficiency, we decided to cut small pieces from the sample and mount them in an epoxy resin carrier. The pieces cut off the sample is usually 1 to 2 millimeter long and about 1 millimeter thick. When mounted, you can have up to 40 samples in one carrier. We combined EDX analysis and LIICP-MS predominantly to get good calibration based on the silicate counts of EDXA analysis. When you look at the examples on the right, you can see that the actual destructive analysis of LIICP-MS is minimal. The ablation crater is very small, around 30 microns in diameter, and the ADXA analysis is non-destructive by itself, but it needs to coat the sample with a carbon film. The destructiveness of these two samples derives from the cost and time perspective. The most time-consuming of the analysis here are opening and closing the analysis and ablation chambers and establish a vacuum or argon-helium atmosphere, where samples need to be changed. If you need to do this for each individual sample, large number of samples cannot be analyzed. However, with our experimental setup, we were able to analyze about 70 samples per day in this fashion. A good alternative which has been developed in the last 15 years and which is now standard in the analysis of Obsidian material is portable XRF fluorescence analysis. And I am aware that you have one of these machines in your institute. PXRF is a quick, reliable, and if properly treated, can provide very accurate results with a high precision. An additional benefit of the machine is that it is more or less portable, which is also allows in situ analysis for example, rock art pigments and other materials which cannot remove from sites or museums. One of the biggest problems with PXRF is that its user usually have to create their own calibration curves to get accurate results, to get from qualitative analysis of present absence of different elements to concentrations. This is usually done within international standards, a reference data bank. These international standards can be purchased and can be used to calibrate your machine. Luckily for Obsidian, such a reference collection has already been developed by the good people from the research reactor in Missouri, and we can use their collection and data to calibrate our own machine for a price. The more modern PXRF equipment comes with inbuilt calibration curves, which are more or less reliable, but can also be extremely expensive. My knowledge of the latest prices are a little bit dated, but a few years ago, a calibration curve can cost several thousands of dollars on top of the purchase price of the equipment itself. If you decide to create your own calibration curve, or you want to analyze a material for which you cannot purchase a calibration curve, here's a rough and dirty example of how you can do an empirical calibration curve yourself. Admittedly, this is a very rough way to do the calibration, and it's purely through the empirical analysis of your references. You can use linear regression curves, where you compare the outputs of your analysis with international standards or known samples where you know the elemental composition, which you have either purchased or created yourself. Based on these empirical research, you're able to get an equation up here, which allow you to transform your raw counts of the machine into concentrations. All of these analyses are only to a certain level accurate, and we call most of the X-ray techniques semi-quantitative, as they never analyze the whole spectrum of all the elements in the sample, which technically you should do to get accurate results. Particularly, most minerals are in an oxidized stage, and you cannot analyze oxygen with this equipment. So these are approximations of the true elemental concentrations of your data. A little bit more sophisticated is the use of the calibration curves down here on the website of XRF Guru, which were developed by the engineering team of Bruker. This website was first established by Bruce Kaiser and is now run by Lee Drake. The process, however, is the same. You are comparing the raw data of your machine outputs with the certified values of your standards. In conclusion, when you're selecting your technique, you have to ask yourself 5 questions. What is the availability and price? What is the numbers of samples you want to analyze? Are you looking at sources or at sites? Is high resolution necessary? And can PXRF discriminate sufficiently? However, once we establish the appropriate technique and have good data for our samples, then we still need to compare our samples with each other. And for that, we need an additional set of reference material. Sources can come in all different shapes and sizes. In archaeology, we distinguish between primary and secondary sources, and here are a couple of examples of primary sources. One such a source can be a mining area, for here on the left side. On the left, we see this chert mining area of Arnhoven in southern Germany. Each of these round dislocations in the ground is a mine shaft. In terms of obsidian, sources can be quite large, with massive obsidian boulders, depending on the type of volcanism. Secondary sources are features where the material has been transported in some natural way or artificial way, and it's not at the place of origin anymore. Classic examples are riverbeds, and which erode primary outcrops and wash nodules towards the sea. These are very common places where people collect usable raw materials for further production. Another example can be workshops where certain materials have been transported and reshaped, for pottery kilns, for example. Here we could compare the geochemistry of waste material found at the manufacturer site to the geochemistry of vessels. Like I said before, the obsidian sources come in all different kinds of landforms. Here are 2 examples from primary obsidian sources from Europe. One is the famous Melos obsidian source. Raw material of it is widely transported throughout the Eastern Mediterranean in the Bronze Age. As you can see, the source today is a hill slope. Each of the black spots here is an obsidian nodule. These sources can be very large, in the case of Melos covering multiple square kilometers. On the other examples is the large sources Chekhov source in Slovakia, today an agricultural field. This source is distributed around about a hectare along a creek bed. If you consider the size of these archaeological sites, you can appreciate the difficulties in analyzing resource extraction patterns beyond the general location of the source. On the other hand, obsidian sources can be very small. Here are examples from the 2 sources in North Vanuatu, which I investigated during my PhD. Both of these sources consist of small obsidian nodules, rounded, so most likely bombs of pyroclastic flows. The Gower source on the right had a layer of these obsidian nodules embedded in a highly weathered lateritic tuff. The extent of the source is what I was not able to identify, but although I only found small nodules in the situ at the outcrop, larger nodules could be found in taro fields in the vicinity of the outcrop. The Vanua lava source is currently only known as a secondary source, with nodules found in the creek beds. Here, obsidian nodules can be found in a very humid clays, which look like secondary deposition. People most likely collected the material from the beach next to the river mouths. The floors of the villages at the site are covered with obsidian fragments, both flake pieces and unmodified nodules. Closer to home, the group 3 source from my example from the beginning was recently identified as local from Alor. Close to the village of Kulunan, obsidian clasts were found by my colleagues Chimuna Kili and Julian Lewis. This source was identified in primary deposition on the southern side of Alo Island. Samples were taken primary deposition from a very fine-grained glassy tuff with occasional obsidian olivine-rich basalt clast embedded. Raw material was not detected in creek deposits at this location, but the topography has been changed significantly because of road building activities, and the possibility of secondary find spots cannot be excluded. Although all the samples derive from the same geological formation, they were found in different elevations, suggesting that they represent several discrete but related volcanic events. To end of my lectures, let's talk a little bit about the challenges of Obsidian sources in Indonesia. Although difficult in terms of fieldwork, an understanding of the source is of utmost importance for a successful geochemical fingerprinting of artifacts. In general, sourcing studies use multivariate statistics to analyze the geochemical fingerprint of your samples. Measurements of elements are ideal for the purpose of these analyses, as they are independent variables which don't have a direct relationship with each other. You can argue that this is from a geochemical perspective, however, being measurements rather than nominal data, they can be used in statistical analysis such as principal component analysis or discriminant function analysis. The differences between these two analyses is that PCA is an exploratory tool where you order your data by similarity. This is particularly useful if you want to identify certain elements which have the highest chance to successfully cluster your sample. At the same time, it can give you a good understanding of how many clusters you have in the assemblage, which you can relate to the number of potential sources exploited at the site. Discriminant function analysis can be used if you already have a good understanding of your source variability, as you need a training set for the analysis. If you have several source samples in your reference set, you can easily use this analysis to identify the origin of your samples. Here you are able to distinguish the sources from each other in the circles here, or the ellipses, but you can at the same time relate the unknown samples with your reference data set. Here, for the example, group 1. This can provide a better visualization of what sources are in your samples, and more importantly, which not. One of the problems with having no reference data sets, as in this example, is that you have an incomplete understanding of the intra-source variability of potential sources in your assemblage. If we come back to one of the slides I showed you earlier, you can see on the principal component analysis that local sources most likely represented in 3 different clusters. I have circled them here in the slide. My initial suggestion was that these were 3 subsources of the same event. However, our analysis of the collected raw materials at this source showed that there are actually only 2 subsources, gray and red and yellow. And there's this separation of red-yellow was only a variation in the same source. These kind of information you won't be able to test without having a very good understanding of the intra-source variability, which can only be solved by analyzing all outcrops available in the region. Let me finish my lecture with a bit of an outlook of what I think is needed to move obsidian sourcing forward in Indonesia. Back in 2011, we published a review of obsidian sources and sites. One of the interesting outcomes of this analysis was that we found many more obsidian sources being used in archaeological sites than found so far. We were able only to source about 40 to 60% of our artifacts successfully. This is even more important as obsidian transportation has been used to identify maritime interaction networks, particularly in the later prehistory. And here was one of the most important one is the Austronesian expansion. However, a review of current research has found that the evidence for maritime transportation of obsidian is exceptionally rare. So far, the only connection of maritime obsidian transport in the Neolithic I was able to find is the famous Bukit Tengkorak site with its connections to maybe to the Talaut Islands and to Mindanao in the southern Philippines. What is needed is more research on the actual sources of obsidian to establish a complete understanding of the obsidian sources available in Indonesia. I'm very pleased to see that this research group is tackling this task with the new research of Ruli Fauzi and his colleagues in Sumatra. We just applied for a new project with Sue O'Connor from the Australian National University to finally identify the obsidian sources of Group 1 in our network and we hope to start surveying in the next year if our application is approved. However, there are many more areas which needs to be investigated. We don't know the origin of obsidian found in the Talaut Islands, nor from the island of Tidora, Puloai, the Kamasi sites in central Sulawesi, or also the obsidian artifacts from Flores. These are all spots which can be investigated, and we hope to see many more interesting results in the future. So with this outline, I would like to finish my presentation, and I would like to acknowledge all the help over the years. I would particularly send my thanks to all of the collaborators from Arcanas, the different balais we've worked with, and the researchers from the University Gadjah Mada. And of course, this research would not have been able without the generous permissions granted by the RISTEC and the Ministry of Research and Technology. Thank you very much.
Thank you very much for the inspiring presentation, Dr. Richard Meyers. There's a lot of information in a very short time, but I would like to make some remarks on your presentation, which is, as we understand that geochemical is one of the most important tools that has been used by prehistorians to expand our knowledge, to understand how humans behave, how humans interact with other groups and those kind of stuff. So, and provenance is very important to understand the reason and how people in the past looking and use specific materials. And you also give some example in three sites, which is the Trombon Lake, Kisar, and Magpan. And at the end of your slide, you gave us not more work, but encouragement to us that there's still more work need to be done in the future in terms of collecting database, collecting more data as a reference, and then how to that to be able to make us to understand more the networking and people in the past. So I would like to invite to our participants if they have any question in terms of our Dr. Richard Meyers presentation. So I hope it will be a great discussion after this. So if you have any questions, just raise your hand or, sorry?
I already have a question in this chat.
In chat, okay. So the first question, I think you might answer it directly, I think. It's from
okay, thank you very much. Maybe I just read the question, and the question was from Ruli Fauzi. It was, obsidian is one of the most easily alterated igneous rocks. It can generate recrystallization due to hydration, for instance, or generate spiralites, etc. Is there any effect of the results of geochemical determination? Yes, if you are analyzing surfaces which have been alterated, this can be a problem. One of the things, usually these alterations are not very deep, so they are very much a surface alteration. Although it depends on the age of the rock and how long it was geochemically alterated in acidic soils and so on. So that is, and this is one of the ideas which I usually have when you see a sort of spread of geochemical elements in your source. So if you guys start to see inter-source variability, there are lots of different things which usually can alterate or can show changes in the sources or in the geochemistry itself. Usually with this weathering process of hydration, though you don't really get changes in the elements which you are really interested in. So one of the major things which we are doing with analyzing obsidians, we are concentrating on a very distinctive part of the elemental signature, and this is what we call mid-set elements. So it's rubidium, strontium, yttrium, zircon, niobium, and these elements are not easily alterated. So they are very stable in the sample. So if you're looking at oxides of major elements, yes, that can happen. But in general, we don't really look at these elements. So, but it's definitely a problem which can be investigated But my point usually is that these alterations, you need to have a very good understanding of the source materials itself, because these alterations, especially hydration, is something which happens over time, but more structural changes takes quite a long time. So if you have, for example, obsidians which are only 2,000 years old, so on, I wouldn't worry too much about structural changes, because the hydrations is really just on the surface. Does this answer your question?
Yes, but maybe to have a more discussion, more further discussion, may I ask directly, Mr. Anton?
Yes, please.
Yeah, because the problem is that we analyze, like for instance, we have XRF equipments, portable XRF equipments in our office, and if we analyze the surface, right, and the benefits of PXRF is like it's safe to be used for the artifacts because we only analyze it's non-destructive analysis. So we rely only on the analysis on the surface of each artifacts. Because so, what do you think about this?
Well, I'm not sure. Do you know what penetration depth you have? So the thing with XRF analysis is that when you analyze the samples, the depth you are exciting with your X-rays is actually different for every element you're looking at. So when I say that the surface alteration is not that important for the more heavy element, it means that you're actually not, and when you look at, for example, rubidium, you're actually not looking at the surface. You're looking at an algorithm, like an accumulation of the surface plus all the material. Most artifacts, one of the problems is that most of the X-rays actually go through the samples. So you're not only analyzing the pure right on the surface of it, but you're actually analyzing everything inside of the sample too. So when I say that surface alterations is a problem, it's really just a problem for certain elements. So for example, aluminium, it's a problem. It's for silicon. Silicon is a big problem because what you're analyzing with XRF is really just 200 microns. So that's really just the surface. And if you have alterations there, yes, that can be a big problem. So but it's also one of the reasons why we are usually don't analyze these light elements necessarily with XRF, and we are concentrating on the other elements, which are more heavy, which pretty much analyze the whole bulk of the sample. And that's the problem. There is more that you get variance in your sample. It's not like that you are say that the sample gets changed so much that you have before you had 100 ppm rubidium, and then suddenly you only have 20. So that's not the level. You increase the error of your samples, and one way around is to just do more analysis. So to get a better understanding of what's the differences is. And if you have sources, you start with analyzing fresh cuts. So you're looking at, with the source material, you can cut it. It's not a big problem, but so that gives you a good understanding of what potential geochemistry would you expect in your samples. And then from there you can go out and say, oh, well, this sample looks very different. So can this be just post-depositional alterations, or is this actually a different source? Does that answer your question? Yes, yeah, but in the end, I think with Obsidian, I don't think this is a huge issue, especially if you're concentrating on more heavy elements, because you are pretty much analyzing the whole artifact and not just the surface.
Thank you. It's answered the question.
I think there is one more question, which is, what do you think about the development of portable technology today in terms of?
I mean, the portable XRF analysis.
Yeah.
Well, one of the I love PXRF. I think it's amazing. So and it becomes better and better. So one of in the early days there was a lot of criticism about PXRF as with it being not a good technique. It's like you get so much variability. You can't validate your results. You're not using it in a proper laboratory processes. You don't have appropriate procedures and so on. These are all valid in some respect valid criticism in the early days of PXRF, because a lot of people were buying it because it was amazing, and a lot of people didn't know what they were actually doing with this technique, and because they were not trained geochemists, me included. But over the last 15 years, there's been a lot of development happening. And one of the major things which has been developing is this whole issue about calibration. So how do you get from the counts you get in your machine? So the machine is just, if to explain it for people who don't know how XRF works. So what you do with this machine, you have X-rays which are emitted into the samples, which are reflected and absorbed, and you have a detector which counts how many X-rays get absorbed by the detector again, and each element has a different energy level, and it's very distinctive. So, but the problem is each machine counts it differently. So if you are using a Bruker, you're going to get a different count rate than if you're using an Innovex. So there's all these different techniques. And one of the things which was done in the early days that people just published their raw data. So if you publish, one of the big things about publishing your data is that there needs to be some certain reproducibility of your data. So you can only reproduce your data if you have the exact chain machine, if you have exact machine and use the same protocols, which is mostly not possible. So that's why we need to calibrate, and that's why, for example, journals have asked more and more that you are publishing your standards with it. You're publishing how you were calibrating your data. That was a huge problem in the beginning, and I don't think this is a huge problem anymore, because a lot of people understand what the problems are. People have become much better in calibrating the data. Companies have become much better in providing calibrations. So it's not this Wild West anymore. There's a lot of development happening, and the techniques obviously become better and better too. So if you compare the early, I don't know, Bruker Tracer 3 or something like that to the new Titan 5, the amount of precision, the amount of count rates and so on is a magnitude better. So you get much better data out of it. So in that respect, yeah, it has been huge strides, but the fundamental fundamental problems persist. The thing is when you are sending samples off to get it analyzed in the lab, then the lab is going to do all the processing. They're going to do all the calibration. They're going to make sure that the data is reproducible, that you have long-term consistency in your data. With a PXRF, anybody can buy it, and anybody can use it. Like, it's very easy to use. But then it's up to the researcher to establish all these protocols and processes to make your data reproducible, and that's the responsibility you have as a researcher. But like I said, most of the time, so I think it has become a lot easier now for the researcher to do these things, because companies have become more aware of these issues. And so there are more tools available for people to use this. The other thing is there's a lot of different techniques always invented. For example, there's now a portable ICP-MS available, which is very expensive, but it probably becomes available in the future for widespread. So there's new techniques which can be used. So that's very exciting. So there's a lot of new stuff happening. But in general, I think the fundamental questions persist, is you need to choose the technique which is appropriate to the archaeological questions and archaeological materials you are analyzing. And that is up to the researcher to decide.
Thank you. Yeah, it's a good discussion actually, because we have our head here, Pak Sofwan, head of Arkeometri. There is some message behind your behind your comments. Thank you very much to tell this the benefits of XRF and the needs of collaboration, needs of calibration on it. Thank you.
I have another question. Is it possible to use this method, geochemical fingerprinting, for organic samples, for example, shells? Okay, it's a difficult question. So the question is, what do you want to achieve with the geochemical fingerprinting? Do you want to find out where it comes from? There's lots of different things you can do with sort of geochemical fingerprinting. For example, if you look at stable isotope analysis, you can talk about precipitation regimes, you can talk about growth rates, you can talk about salinity in the in salt and fresh waters and so on. If you look at sourcing, trying to find out where the shell actually comes from, I would say it's not impossible, but it's incredibly difficult. So normally what you can do is, usually you wouldn't analyze the shell like the calcium itself. You should look at impurities or contaminations in the sample, which you might be able to also find in the environment where it might come from. So if you have, I don't know, mercury poisoning in a certain area and you find mercury in the sample, you can do that by geochemical fingerprinting. In general, organic materials are very difficult. There has been some research been done on pigment binders. So organic materials which have been used to mix pigments and then analyze this. I wouldn't, it's not traditionally the same way we would analyze rocks or ceramics or this kind of material. Organic materials are very difficult.
Thank you very much. Any questions? Or maybe Pak Sofwan want to elaborate?
Thank you for your
explanation. Okay. I think there is another question. Yeah.
We haven't. So
it's related to the previous question. Yeah.
From Angus. Yeah. Thank you for this question. I'm not aware that we have done any pigment analysis on Kisar at the moment, but this is definitely something which would be very interesting to see. The problem with pigments, especially rock art, is that the pigments have to be very distinctive to be able to match. So Gillian Huntley is one of the major people who is doing pigment analysis in Australia, and it's probably impossible with PXRF. I tried it a few times, especially if you're looking at in situ analysis. You need to have very specific pigments being used. I did a study ages ago on lead pigments, which have been used for certain as a raw material for certain types of rock art in North Australia. But in general, the problem is that most of the pigments are some sort of derivative of hematite, and so what you would need is you would need a very good understanding of what kind of hematite has been used. And again, you would probably not look at for example, hematite is majorly the major aspect of the pigment is iron, but iron wouldn't look at iron. So you would look at again at the combination of elements, whether you see a specific element being very abundant in it, and then having a match of it. But I'm not aware that this has been matched.
Okay. There is another question, I think. It is interesting lecture that obsidian occur in several islands in Nusa Tenggara Timur. Is there any obsidian artifacts were found outside these islands so far?
Yes, a lot. The Ruli Fauzi and his team is working in Sumatra, where the whole Jambi region, there's a lot of obsidian being found. And interestingly, it is very persistent, the obsidian usage throughout the years. So it goes all the way up to the late Iron Age, as I understand. So obsidian, one of the most famous one is Bandung in Java. It's one of the most famous obsidian region, where there's a lot of obsidian being found, close to, it's not that far away from Jakarta, which that area can use a lot more research. I think it's a very interesting area. Particularly, I would be very interesting to see when it actually been started with the analysis. There's some research been done, but I would like to see some more dates from that area to see whether we have, I don't know, an upper Pleistocene or late Pleistocene usage of this obsidians. We know that it's been used in later periods, but I would be very interested to see how it has been used in the earlier time periods. Flores has obsidian. We found obsidian both in South Sulawesi as well as in Central Sulawesi, as well in Northern Sulawesi. So there is, which also has quite a time depth to the usages. And then we also have the famous Talaut Island obsidian, which would be very interesting to see where that comes from. We don't really have a good idea whether maybe it came from East Kalimantan. It's always been thought that the interesting Sabah connection there, that it is a eastwards connections, but it might as well be a westward connection. So that the obsidian has been transported from Borneo or from Kalimantan from Sabah to the Talaut Island. So there's a lot of different obsidian sources. Now, obviously, with Indonesia being one of the most volcanic active regions in the world, there is just a huge amount of potential there for obsidian to be created. So I think there's a lot of potential there, and obsidian is, to answer your questions, there's a lot of obsidian. Ruli again, so not a question, only a comment. There's no problems on technology or references. Problems arise when. Okay.
We all have the same problems for sure.
Okay. Well, I mean, like I said, normally most of the statistics is fairly straightforward. I'm not sure which kind of programs you're using. I'm using PAST4, which is a very simple freeware program which can be used. Obviously, you can use R or something like that if you want to be a little bit more involved in all the whole. My thing with R is always that there's a fairly steep learning curve, and unfortunately involved with this, but there's a lot of fairly straightforward programs where, and the good thing with Obsidian is that the data usually itself is really not that complicated. So because most of the time you can reduce your data on a few attributes. So maybe you look at the 5 general mid-Z elements, and then you add manganese and titanium or something, or so you have 7 elements. So it's actually not that complicated. It becomes complicated when okay, in your case, really, you have a couple of sources which are very similar to each other. So then when you go into more and more detail, then it can become complicated, but in general terms, I always think the obsidian itself is actually quite a thankful raw material to work on and start with. If you look at other raw materials, for example, and if you look at any sedimentary rock or you look at clays or so on, it becomes very complicated very quickly, and you need quite a bit of geological background to understand what's actually going on in your geochemistry. But obsidian is a thankful. It's a very, very easy material to start with. And then if you want, you go down the rabbit hole and you start using techniques on all different kinds of things. Yeah. Don't despair. That's what I'm saying. Don't despair. It's just numbers. Oh, okay. Yeah. I know. I'm not a big fan of SPSS, and SPSS actually also not been used, not been developed for this kind of analysis. It's a very complex system which been used for a lot of data which is not numerical, like not measured. So although you can use all of this, it's actually an analytical tool in the social sciences where you do have a lot of qualitative, so nominal ordinal data, and there it is really good. So for numerical data, which is really, it's actually from a statistical point of view, it's kind of the more simple things, it passes just easier, and it's. But the thing, one of the most important things, and I don't know whether this came across when I said the differences between PCA and discriminant function analysis, is I would be very careful with PCA. It is, for me, I always just think it is just an exploratory tool. So you just get a basic idea of what's actually going on in your data set. So because the clusters you see, and I hope this came across, is not 100% sure what are these clusters really are. So sometimes it can be a little bit unclear. So if you have a good reference set, and this is why I think the Obsidian source, the sourcing of the sources themselves is so important, because with a good reference set, you can get rid of all the ambiguities you get in PCA. You can just use a discriminant function analysis, and it really just sorts your assemblage, it sorts your data in a way straight away how you want to have them. And you actually, on top of that, even in past 4, you get what they call confidence intervals. So you get the idea of the spread of the variability in each of the source, and you can say, oh well, this is sort of the area which I'm looking at, and then you're going to get a much better idea of how the sources are discriminating from each other. So if I make a recommendation, is I would use PCA always just to get an idea about your data set and see what's going on, especially also get an idea about what are the important elements. And I don't know, this is for me, when I read PCAs, I find it always interesting that you also add this little B plot in the corner where you can see which kind of elements you've been using, and you can see how strongly the different elements impact your data set. Because eventually, if you have one element which pretty much sorts everything, you can get rid of all the statistics and you just look at 2 elements, you just do a biplot and you get a nice sorting, and you don't do any statistics at all. You're just plotting your samples. If you have an understanding of what the variability is in your sample, and then nobody is going to question that. If you have a good spread in just 2 elements, and that's not a problem, and you don't need to think about statistics at all.
Any question? I do notice that there's among the participants, there's people who came from research organization for nuclear technology. I think it would be great if they have any question or maybe some
please no.
comment. Maybe some comment.
Actually, we have AAN right?
NAA.
NAA.
So the
ANA,
neutron activation. Yeah, great.
ANA.
Yeah. I saw that you have that. I'm very jealous. The problem is with NAA is I would, if you, so again, so when I would plan a sourcing study where you, for example, analyze sources and samples, I would do all the heavy lifting on the sources. I would, if you have NAA available, I would do most high resolution analysis on the sources themselves, because then you have a really good idea of what the variability of the sources themselves are. And then when you look at the artifacts, you can use all of these non-destructive techniques because you know already very well how your sources look like. And nobody cares about the geology. That's not true, but it's like if you have a hand sample, a geological hand sample, I don't think there's going to be a huge issue in cutting it and taking sample material, taking large sample materials, for example, to get very good data of the sources themselves. And then once you, like I said, and then once you have a very good understanding of the geochemistry of the sources themselves and the variability in the sources and which are the elements you're really interested in, you might be able to, with the PXRF, you just calibrate your PXRF on 2 elements and you already know these are the 2 elements I'm interested in. And you just run all the samples, you have all the artifacts very quickly, and it sorts very perfectly in this reference data set, which you establish with a better technique. I hope you agree, from the geochemists from nuclear science. So I think that would be the better, that would be a really good plan, how you would plan a sourcing study if you have these kind of techniques available.
Okay, thank you very much, Dr. Christian Meyer. I think if there's no other question from the participants, I would like to say thank you very much again.
It was a pleasure.
It was very short, but there's a lot of information, and we would like, we are hoping to have a collaboration research in the future, maybe. Or maybe if we have any question or just want to have discussion, we could just send email for you, and then we could have.
Absolutely.
That would be great for you. I think
yeah.
For us, for sure, that would be great. It's our privilege. Thank you very much. So
thank you.
I'll give time to our Master of Ceremony, Marlene. Thank you.
Okay, thank you so much. Mas Anton telah memandu kita dalam acara ini, dan next will be heard a closing statement from Dr. Sofwan Nurwidi as the head of the Archaeological Research Center for Arkeometri, and also by Dr. Richard Meyers. Untuk Dr. Sofwan Nurwidi, saya persilahkan.
Thank you so much, Marlene. Actually, there is another one question from YouTube. It's okay. Okay. Thank you so much. And Pak Heri Yugaswara, our honorable chairman of Research Organization for Archaeology, Language, and Literature, our honorable guest lecturer, Professor Christian Richard Meyers, researcher from the Commission for Archaeology Non-European Culture of German Archaeological Institute, and all of our colleagues from various institutions who joined this lecture series by Zoom meeting and YouTube. Thank you very much for your participation. As stated by Marlene before, this lecture is actually a forum for capacity building for us, especially for researcher in the Research Center for Arkeometri. And as presented by the lecturer, there is many opportunities for us to use this quite new approach, what's so-called geochemical fingerprinting, applied for various archaeological data, such as Obsidian, as presented in this lecture. And Professor Richard Meyers already saw us. This method is very useful to understanding various historical events. such as cultural diffusion or maybe human migration identified by this chemical DNA as fingerprinting for material studies. And there are also many opportunities for us to build a collaborative work between archaeology, nuclear technology, earth science, chemistry, etc., that we could realize in the future, probably between Sumatra and Lasar Sunda project. And finally, on behalf of Research Center for Arkeometri, we would like to express our gratitude to Professor Christian Meyers for this wonderful lecture. And thank you very much to everyone for their active participation, and also appreciation to the organizer who prepared this event. We apologize for any misgiving and hope to improve in the next webinar event. And finally, wish you all good health and see you the next time. Thank you, Marvin.
Now it's me.
Yeah, please.
Yes. Okay. All right. I didn't want to just talk. So thank you very much. I really appreciate the opportunity to talk here. I really appreciate the opportunity to meet all of you, and I'm very happy to see so many familiar faces in the online. So yeah, so many familiar names of the here on Zoom, and names on Zoom. I would like to thank the opportunities to the organizers to let me speak, and I really hope that these new centers and all the, I'm very happy that there's geochemical research done locally in Indonesia now. I think that is very important. I think because geochemical research has a huge potential to give really interesting data, really interesting understanding to past, Indonesia's past. And for me personally, I'm very pleased that there are now so many opportunities also for young researchers to come through and have these opportunities in Indonesia locally, and not that samples have to be sent off overseas. So this can be done locally. I'm very pleased also to see that there's a lot of publications coming out of this research group. I want to highlight Ruli's publications there. I'm very pleased to read them. I think it's a great work you've been doing in Sumatra, and I hope you're going to continue doing this. Yes, so I would like all the excellences for these opportunities, and I'm really looking forward to collaborations in the future. I have to apologize that I've not been in Indonesia for a while now. There has been problems with my funding regimes, and then obviously COVID has stopped a lot of things. But now that the pandemic is hopefully sort of under control, new future endeavors will come shortly. So I'm very much looking forward to meeting you all in person and working with you. Thank you very much.
Thank you very much.
Okay, so yeah, thank you so much for wonderful closing remarks from Dr. Sofan Nurwidi and Dr. Ratmaya. And what we have learned from this webinar, where we have a lot in all aspects, I think. And finally, again, in behalf of the Arkeometri Public Lecture Series team, I would like to express our appreciation to all participants in this webinar, Bapak Kepala OR Bapak Heri Yogiswara. Saya juga lihat ada Bapak Profesor Aiwayan Ardika, Mbak Retno Handini, Bapak Dr. Lutfi di Zoom, dan juga yang lainnya mungkin saya tidak sebutkan namanya. And thanks to our speaker, Dr. Christian Meyers, for the fantastic insight. Thank you, sir, for this wonderful intellectual, and vielleicht ergibt sich in Zukunft eine Forschungspartnerschaft. And yeah, so now that's all that I want to say, and yeah, so this end until this now, and so thank you so much.
Thank you and goodbye.
Thank you very much. Goodbye.
Thank you very much, Dr. Christian. I hope we can meet in IPPA, right? For
Yeah,
next
unfortunately, yeah, it needs to be a different conference because I'll probably only be there virtually. Unfortunately, I'll be in the field by myself,
Wow.
but next time. But I hope next year we will be in Indonesia. So, and then we're going to meet for sure.
And don't forget to spread the news about the potential collaboration under the what do we call in the program?
The research scheme, yeah. The program.
Yes, the
I
program
already have
for
been speaking. Yes,
for
yeah, I've been
the
talking
associate
with.
researcher and etc.
Yes, I will do that. Thank you very much. And it's
Thank
a great scheme. Thank you.
Yes.
Okay.
Thank you very much.
Again, thank you, Dr. Christian. I hope we can see you in Indonesia if you have time to do that.
I very much hope so that the funding is going to come true, and then we're going to be able to come.
Thank you.
Okay.
See you.
Thank you. Bye bye. Bye.
Thank you, Marlin.
Thank you, Pak Christian.
Thank you, Mas Anton. Thank you, Mbak Marlin.
Terima kasih. Terima
Pak
kasih.
Marlin
Pak
seperti
Heri,
melihat
terima kasih,
sesuatu
Pak
ya.
Sofwan.
Pak Heri, Pak Heri. Upacara, Pak.
Upacara udah berapa jam nih Mbak Marlin upacara? Begini terus.
Wow.
Silau.